Assalamualaikum and good afternoon again. Uh, Welcome back to our class. So I'm so sorry because I involved in the ESC accreditation, and also I think some of you also are selected to become one of the interviewees by the panel EAC. So I believe that is your good experience. To be honest, we didn't know what you said to the panel and what the panel said to you, but it's okay. It's already finished. So we have finished already the EAC accreditation visit for the new batch. Okay. So last Wednesday and Thursday. Okay, last Wednesday and Thursday. Okay. So that's why I need to cancel the class. Even I think last week also I didn't say that the class is cancelled because I didn't have time. Okay. But Alhamdulillah already finished. So now we can go back to our business. Okay. Until now until now, okay, until now we have covered until the I think we have selected the inverter, the ratio 0.9 and 1.0, and then we have finished the voltage matching between the inverter and the power PV modules. Then we know already how to calculate the maximum numbers of the modules in the string and minimum numbers of the modules in the string, maximum numbers of parallel connection also we have covered already. So now we are going to proceed to the cable sizing and the system performance. So this cable sizing, we are going to play with the cable 2.5, 4.0 and so on. Okay. Before I start, any questions? Before I start, my voice is clear. Okay. Okay. Alhamdulillah. Okay. So let's proceed. Okay, let's proceed. So cable sizing and system performance. Okay. So power losses. Unfortunately, the solar power that impinge on a solar array each day cannot be completely converted to electrical power in the grid. So, though for example we have the full system of 100 megawatt DC, for example, uh, logically and whatever we did, we can't get the 100% the 100 megawatt DC due to several losses that we have discussed before. So these are the I mean the what about that the summary. So the summary of the losses that come by nature or come by what you call when we have the PV module, then we have already that losses. We cannot do anything. Okay, right. So the first one is the efficiency of the PV cells modules. I will say that the typical efficiency for modules maybe varies from 20 to 25%, maybe. That's a typical efficiency of the PV module. Okay? And of course, there's difference between the monocrystalline and the polycrystalline. By default, monocrystalline are much slightly efficient than the polycrystalline. So that's by default. Okay, next is the temperature of the PV modules. You all play already with the temperature coefficient. Okay, we agreed already the temperature coefficient. When the temperature is getting higher, then the voltage is going to significantly drops. When the voltage drops, so the total power will also drop. So that's the temperature of the PV module and factor from the temperature. Okay. By default for the PV module, for the monocrystalline, polycrystalline, and majority of the PV modules are affected by the change of the temperature. This is the thing that we need to accept as it is. We try maybe some PV modules manufacturers are trying to increase the improving this factor, but still they're still there. Okay, there's nothing we can do. Okay, next is dirt factor. Okay, dirt. Like I told you, if we plan to install the PV in our home, for example, normal home, I mean the normal neighborhood. So I think there's 5% is the maximum, maybe 3%, 2%, depends on the question. But if there's a construction near to your place, or there's a what we call that, desert sampai sekarang saya confused kan, desert ke apa benda, padang pasir, near to padang pasir for example, in the Arabic country for example, that is the difference. I mean the depth factor are more because there will be the sandstorm and so on. But if in the normal place with have the very what we call the average typical numbers of rainfall, I think the 5% is the maximum lah, around. And then manufacturer tolerance, this is what we have learned already. Yeah, kuat sikit. Tak dengar. Okay. Tak ada. Tak ada. Tak ada. To be honest, nothing. We cannot measure the depth factor, just the assumption. More to assumptions maybe. 5%. Later ada sikit lah, ada sikit dia bagi secara rough je. Berapa depth factor secara spesifik tu tak ada. Boleh. Tak boleh nak measure lah. Tak boleh measure. Okay. Right. So manufacturer tolerance, we agree already that the plus minus one, the plus minus 3%. I mean, we are looking for the worst case, which is the minus one. For example, if we get the PMP of 100 watt, minus 3% means that the power can vary from 97 to 103, for example. So the minimum one is 97. If they said that we have the plus minus 3%. If the minus 3%, so means that even in the peak condition, STC condition also, it can vary. But recently, I think if you check the recent models like the SunPower or other brand, they are now improving to the minus 0 and plus 5%. Means minus 0 means perfect. The minimum is 100 to 105 because we need just the minimum one. So means that the tolerance is the FMM 0 means perfect lah. I mean tolerance is 0 but the FMM is 1.0. So perfect lah for the case of the merchant tolerance. So this is the part, this is the job for the manufacturers lah. Again, this is not the thing that we need to think. So we just have the data, then we consider it. And then voltage drop in DC cables to inverter. Because the solar system is based on the DC, so the critical part is on the DC side. So it's all about the length of the cable. The longer the cable is, the higher the voltage drop is. So the best one is to make it shorter. But if we make it shorter, then it's not easier for us to do the proper wiring because the length is very short. So if we plan to do the longer one, then we need to choose the thicker cable That's the different story lah. Okay. But still, there's the voltage drop in DC cables to the inverter is one of the critical lah. That 3% is all about this. And then inverter efficiency, okay. Recent technology, I think can goes until 98.7% of the efficiency. Very efficient, until almost 99%. So technology is getting better and getting advanced. That's why the efficiency also, the manufacturers can suppress it, okay, to the maximum efficiency. Next, voltage drop in S cables to point of connection to grid. Of course, this is also the voltage drop, but this is not the main points here because our job for the GCPV, grid connected PV system, it caters until inverter. Okay, we have the panel, we have the inverter, then after that this is DC. Yeah, of course, until the substation. I mean from here to the Pencawang. For example, 11 kb and so on. This SC lah, AC cable also until the switch gear, I think, it's will the cost of the installation also will be borne to the developer. I mean, if we are a developer for the solar farm, also we need to pay for the AC side. I mean, the until the pencawang. I think until the switch gear level, main breaker, something like that. Until that level, so still it's from our side lah. The cost is borne by us. Eh, developer punya cost lah. Then shadows, because if the shadows can create hotspot lah. That's why the shadows may comes very shorter time. For example, because the sun is moving in, the sun's moving from the east to the west. So during the movement, maybe there's some angle or some specific hour it is blocked slightly by the trees, for example. So that shadows. That's why it's very critical to do the site analysis, site visit before the installation is going to be proceed. Aging, okay, aging. By default, PV module can goes up to 15 to 20 years around. Okay, 15 to 20 years around. Tilt and orientation angles of the PV array is also play a role. So if the proof is solar tracker, kan? Solar tracker is better lah, because the always adjusting the tilt, the angle of the modules toward towards the day. So it's following the movement path of the sun. That is, to be honest, if we have the solar tracker, then is by far better lah for the generation. Yeah, siapa tu? Siapa tu? Siapa tu? Naufal. Yeah. Hmm. Oh, nanti tu. Okay, very good argument, because I haven't asked yet the yang solar farm paling contoh yang Rompen tu lah, yang 30 mega kan. Saya belum masuk lagi. Saya tak tanya lagi macam mana. Bala ke tidak? Ayat berbala tu kasar kan. Saya rasa uh, it's all about the ROI, return of investment lah. Saya rasa dia pasal ROI tu. Berbala tidak tu certain kalau track sepanjang tahun, sepanjang hari, generation can be maximum. Always. Every time tu can be maximum, can be drive to the maximum. So in term of generation tu mungkin dapat extra instead of the very plain atau fixed plain. Secara jujurnya, kalau tracker tu macam mana pun setiap every specific hours tu it can drive the generation to the maximum. Ini solar tracker punya. That's the advantage of solar tracker. For the cost, I think they use, not sure they guna belting ke, saya tak pasti tu. Pakai extreme servo motor besar tu, saya tak pasti tu. Generation, like I told you lah. For example, the good example 41 yang pekan kan, 41 mega kan, megawatt DC kan. Tapi the exported one is only 30 megawatt. So I think the 11 megawatt tu untuk supply yang tracker tu kot around. And considering also the losses, mungkin pada mereka berbaloi kan. Sebab ada solar tracker tu, sebab generate tu mungkin boleh siap awal, boleh achieve. Tak ada isu kat situ mungkin. ROI tu tak pasti, tak tengok kontrak pun. Mungkin lebih panjang ke, tak tahulah. Ataupun okay, tak tahu. Allah Ta'ala alam, tak ada jawab soalan tu. Berbaloi tidak tu subjektif. Boleh Naufal? Saya tak boleh nak ni. Kalau kita, even kita tanya developer pun mungkin kata berbaloi, dia berbaloi. Mesti kan, confirm lah kan. Terbaik lah. Solar tracker tu semua orang agree. Everyone's agree that the system with the solar tracker will produce the best one. Whatever it is. Sebab dia track sepanjang masa. Sepanjang masa, every time can be maximum. Compare to the yang fixed plane kan, macam dekat gambar kan, dia ikut bukit, ikut the structure, they are following the contour of the hill kan, the hill shape. Even though they have the MPPT function for the inverter, but still kalau maximizing tu, I think that's the source tracker is the better one, whatever it is. Macam tu Naufal. Boleh? Ha. Ya. Yeah. Yang mana? Auto drop ni. Okay. 3% yang saya tengok macam standard tu, we are referring only for the DC. AC tak usik. AC tu mungkin dia comply seperti biasa punya standard TMB punya. Mungkin. Tapi yang kita cerita sekarang ni is all about the 3% is on the DC side. Macam itulah. Our job is to deliver the power kan. Inverter tu. Tapi yang dari tu betul lah, AC tu memang kabel kita kena bayar lah. Pull the cable from the the inverter until the, I think not inverter, step up. There's step actually in the solar farm. I think there are step. They have transformer step up into 11 kV. Then from that 11 kV will travel several kilometers until the pencawang masuk. So that until the breaker side also is, the cost also is on the developer lah, owner because baru first tanya banyak Okay, dirt and soiling, just the we have some explanation here. Dirt and debris such as leaf build up on the surface of PV module. They will shade the module and reduce its power output. Reduction in power output will depend largely on the site and the factor influencing soiling, such as the tilt angle and which the modules. Yeah, Ashraf tadi. The rating factor due to soiling can only be estimated. Specific berapa persen tu, itulah dia jadi macam ni. It's fairly common practice to use after 10% reduction due to the soiling for very dirty sites and 0.95 reduction due to soiling for relatively clean site that experience regular rainfall. Assumption kan, nampak? That's the common practice lah, macam tu lah. Very dirty site, I think on construction, if you living in a very critical construction kan, it requires a lot of dirt and dust, and that one maybe can consider 10%. But for that case, I think people are not going to install the solar farm there lah, the PV. It's not during the site analysis also it's already fail lah maybe. Not fail, I mean maybe reconsider lah. When you see there's a lot of construction, maybe we don't usually install the solar farm. Okay, if we see there's construction that can last 2-3 years macam tak siap lagi kan, so kita tak proceed lah untuk situ. Tapi regular rainfall tu 5%. However, in the question depends on me lah. I put 1%, 2%, 3%, it's everything on me lah. Okay. Okay. To be honest, they are not considering the karat or so on. Saya rasa dia tak consider langsung karat-karat semua tu. Dia proceed aja, Sebab dia mungkin sebenarnya dia akan effect to the durability ataupun apa tu panggil lifetime of the PV modules tu. Saya rasa lah. Mungkin 15 to 20 years tu we reduce kan, but at this moment I think there's no authorities yang check tak sesuai ni, kat tepi laut ni mungkin lebih pendek. Tak ada lagi apa-apa statement berkaitan tu. So saya rasa dia just proceed with the installation macam tu je lah. Tapi but for the hydroelectric ke ataupun tidal electric ke, because they are submerging the turbine, submerging the tools, equipment in the sea, in the water, and that one I think they consider the dust. Okay, the dust, then they consider coating untuk anti rust punya. Tu memang akan consideration lah. Tapi solar ni saya rasa, to be honest, dia just install and finish lah. Okay Ashraf, boleh? Pengaratan tu they don't consider lah, I think, the rust. Boleh Ashraf? Boleh Ashraf? Ya. Oh, hilang dah. Gila. Okay. So saya proceed. Boleh? Saya proceed Uh, okay. Manufacturer tolerance. Okay, manufacturer tolerance already mentioned before macam ni lah. We are consider only the minus. If you don't see the minus, so means that perfect. I mean minus 0 plus 10%, sometimes 5%, sometimes 10%. So we don't care about the plus value. What we care is the minus one. Okay. Recent manufacturers of the PV models, they can provide until 0%. Means that perfect. Perfect. So if we calculate the FMM, is 1 minus 0, so mean 1.00. Perfect. FMM. Okay. If while looking for the tolerance, for example, in data sheet kan, because in calculation you need the value for the tolerance, and then when you try to find it, we cannot see. I mean, we cannot find in the data sheet nothing. Uh, Warranted power also we don't we can actually if we don't see the tolerance, uh, usually they said tolerance, power tolerance, manufacturing tolerance, that words. Okay, that wording is the clue. Okay. And if you see the plus minus, to be aware of that, plus minus percent, that is the meaning of the power tolerance, maybe, if we near to the watt. Okay. What will happen if the value is not given? It's actually, saya tak ada contoh kat sini. We also can estimate the tolerance, the value of tolerance, but with one condition. Okay. Usually they're giving you the value of PMPN. Kan? Biasa PMP, for example, 100 watt PMPN. Okay. Some data sheet, some not all, some. They're given another value. Power also, but different wording. Warranted. Warranted power or guaranteed. Guaranteed power or minimum. Minimum PMP. Also, that's what they have that kind of wording. I repeat, if you can't find the percentage of the tolerance, you try to find everything here and there, you cannot find that. Then please search for this wording. Okay, warranted or guaranteed or minimum PMP. Mean warranted power ke warranted PMP ke whatever lah. Warranted power, guaranteed power, minimum PMP. Usually this value will be slightly lower than this. For example, 97 watts. The clue is this value will slightly lower than PMP. Okay. Slightly lower than PMP. So from the, if you see this kind of value, warranted, guaranteed, minimum, then you can calculate the tolerance. How can we calculate that tolerance? So tolerance equal to PMP minus that guarantee value. Guaranteed or warranted, guaranteed, what call that? Warranted, guarantee, minimum over PMP STC lah. Multiply with 100. For example, for this case, 100 minus 97 over 100, then you're going to get 3%. 3% means minus lah. Okay. So the tolerance is 3%. Okay, tolerance is 3%. Boleh? Boleh dapat? Tak boleh dapat? Bisa enggak? Tanya siapa lah? Uh, Fahim, boleh Fahim? Fahim Nazmi. Boleh dapat? Kalau tak bagi value tolerance tu nak kira macam mana? Berapa senyap? Kalau value tolerance tak bagi dalam atas sheet, then kita calculate lah. So calculate macam yang saya ajar ni lah. Ke tak clear? Tak faham soalan. Okay. Settle Kalau tolerance, manufacturer tolerance tu tak bagi value tu, kau cari-cari tak jumpa langsung. Percentage plus minus 3% apa semua tak jumpa. So nak buat macam mana? Sebab kita ada calculation yang kita perlukan FMM tu. Means that kita perlukan lah tolerance tu. Dan bila cari-cari tak jumpa. Kan? Betul? Okay, bila tak jumpa tu nak buat macam mana? That's why kita cari wording, kita kena cari wording. Ni, wording ni. Warranted, guaranteed atau minimum PMP yang biasanya the value is slightly lower than the PMP. Contoh, if the PMP module tu 100 watt, usually that minimum value tu contoh lah 97 or 98 or 99. So from there, we can calculate the tolerance. Macam ni kira dia. PMP tolak yang guaranteed value tu, bahagi dengan PMP, then dapatlah persen. Persen tu lah yang tolerance tu. Begitu. Boleh? Khairul Nizam boleh? Boleh. Okay, saya consider boleh lah. Kalau tak faham, boleh direct tanya kawan-kawan atau tanya saya lah. Okay, tanya kawan-kawan boleh. Alright, shading and module orientation can be a major contributor to loss of system performance. Apa nama tu? Shading. Voltage drop. Because hotspot is created. Hotspot is created. It's not the personal hotspot of the Wi-Fi. It's the hotspot. Okay. So PV array is shaded. If the PV array is shaded, the voltage drop. So when the voltage drop, this is what we afraid drop outside the inverter voltage window. Ini kalau ingat lagi lah. So this is the, saya boleh tak ingat dah, Vmin berapa dia tu, window allow, apa benda tah, minimum voltage, minimum voltage for window, minimum window voltage, okay, of the inverter. If the value of the output from the PV voltage tu, sebab ada hotspot, drop, so if that value is lower than the inverter punya input, will not turn on. Okay, inverter, it will cause the inverter to turn off and the system will produce no power. Faham kenapa the hotspot will affect to the output of the power that we supply to the TMB. It's all about because the voltage will drop. Okay, the voltage will drop, then it doesn't meet the minimum requirement of the window voltage of the inverter. That's why at the time when it's not in the range, ni macam ingat tidak kan korang ni? Dah bore aku. MPP voltage, for example 250 until 800 for example. Okay, 800 volt. This is the MPP voltage range. Where the minimum one is 250, but remember kan kita ambil 1.1 kan, margin. Okay, if that value is lower than 250, means that the inverter will not turn on. Once will not turn on, nothing can be fed to the TMB. So that's the critical. Okay. When multiple things are connected in parallel, the shading on one stream may impact on the others. Macam saya cakap kan, kalau satu disambung secara parallel, dia akan kacau. It will the lowest value voltage tu dia akan follow yang the lowest voltage punya string lah. If we connected in parallel. That's why critical lah benda ni. Okay. And maybe that is one of the reason why we do the very single line, I mean the single string only with the less input kan, inverter input tu kan. Apa input current tu just maybe 10 amps, 11 amps means only one series. So that one maybe we can reduce the possibility of this kind of hotspot phenomenon. One of the reason. Current and voltage are directly affected by the irradiation received, and when the module is shaded or not a proper tilt angle and rotation, it does not receive as much irradiation. Okay. Okay. We are going to the part that we call as current carrying capacity. I'm focusing only for the DC, I mean the for solar cable. CCC ni I think most some of you maybe know. The rated maximum current for the certain thickness and a certain type of the cable. It also have for the DC cable, AC cable, and also solar cable lah. We are focusing now on the solar cable. Okay, so this CCC is referring to the solar cable part. Okay, any conductor will have a safe limit when current passes through it. This is commonly called as the current carrying capacity. So there's a safe limit for the maximum current that can be flown through certain cable. Okay, certain size of the cable, certain type of the cable. The CCC of the cables is affected by cross-sectional area, millimeter square, type of insulation around the wire, and environment. Okay, the CCC can be affected by we call that cross-section area. And then the size cable, the cable size of the 1.5, 2.5, 4.0, 6.0, 10.0, 16, and so on. So remember, this is not the thickness of the cable. This referring to the cross-sectional area of the cable. And the copper one, I mean the inside one. So it's all about the cross-sectional area. It's the area. Okay, not the thickness. Okay, 1.5 millimeter square is not the meaning of the 1.5 millimeter in thickness. No. Okay. And also, it's not the diameter also. It's actually the cross-sectional area. Don't get confused, Okay. The Malaysian standard MS-IEC 60364-552-2003 includes tables showing the CCC of all different type of cable in different environments. Different environments too means that when we talk about environment, it's all about the T cell lah, to be honest. The T ambient and T cell, okay? Or the T ambient temperature. Okay, T ambient. This is T ambient. So environment means T ambient ambient temperature. Depends. It's not same for all degrees. For example, 30 degrees C is not same with the 70 degrees C situation. It's different. And that has the table, okay? The minimum current upon which the table cross-sectional area should be chosen can be calculated as, okay, so ini adalah minimum current upon which the table cross-sectional area I minimum string is equal to the 2 multiplied with IAC STC string. Okay, I minimum string equal to 2 multiplied with IAC STC string. Okay, and then I minimum array is equal to 1.3 multiplied with IAC STC array. Okay. Okay, it's all in the cross-section area lah. Maksudnya depends on the cross-section area. Then we find the cable that is suitable for this kind of application. Kita tengok sini. So this is the table of table 6.1 is CCC ratings at different temperatures. However, so I'm quoting this wordings and this reference from the SEDA. Okay, ini buku SEDA yang GCPV lah. So walaupun the sources is quite old, 2005, which is 70 years old already. But since it's stated in this book at the CPB Seda, so I just following there. Okay, so I just follow. For example, AEG solar. Okay, AEG is type. It's a type of cable. I think brand also lah brand. They have AEG solar. They have the Redox 125. They have the Titanex 11. So there's the type of cable. Okay, type of cable and company also. Okay, cable CSA in meter square. We are focusing on the 2.5 and 4. Okay, maximum DC current for various temperature. So this is the critical one. Okay, ini yang kita nak tengok. What is the maximum current for that specific cross-sectional area of the cable? For example, if we plan to use the 4.0, if we plan to use 2.5 millimeter square, what is the maximum current that can be flown through that cable? Usually the maximum current is all about the parallel connection. You know, if we do parallel connection, so the current will be multiplied. When the current will be multiplied, so it's very important for us to check the spec. So this is what I'm talking. This is what I'm talking. We are talking about the single. Individual lead mean individually lah. The cable is not bunch. Okay. This part is accumulation 6 cores in a bunch. Jarang lah 6 core. Biasa kita dengar 5 core kan. 5 core cables. Yang satu insulator tu di dalam tu ada 5. So 5 cables inside there. So 5 cores. But that one is 6. It's okay lah. We're not focusing on that. Because mostly solar cable tu is individually lit. Maksudnya individual lit ni positif kabel lain. Okay. Negatif different cable. There's 2 cables. Separately lit. So we call that as individually lit. So kita akan refer yang ni lah. Okay, for example, we plan to use only 2.5 millimeter square due to our budget, because we are student, we don't have much budget, so we want to reduce the cost as much as we can. Okay, let's consider at the highest temperature, which is at the worst scenario. Worst scenario means the minimum voltage lah. The minimum voltage condition means that the highest temperature. Here the table that we have here 70 degrees C. I think Malaysia cases 60 something. Okay lah, you can refer 70 degrees C. Okay, means that 2.5 millimeter square of cable can support up to 24 amps DC. The maximum current that can be flown by a 2.5 millimeter square of cable, AEG Solar for example, AEG Solar brand, okay, AEG Solar brand, can goes up to 24 amps only. If more than that, then the cable will melt, especially during the highest temperature, because it's getting very hot. That's why the solar cable also is suited with the, what we call that, UV resistant, flame retardant, apa lagi lah, high temperature, okay, high temperature, UV resistant, flame retardant. That's different between the solar cable, the insulated one, double insulated solar cable. Solar cable is double insulated. There's a difference between the solar cable and the DC cable. Normal DC cable is like the cable battery, battery cable. Okay, only single insulator. What I mean is, if we cut the cross-sectional area of the cable, so this is the copper one. I mean this is the cable lah. The conductor kan. So there's a double layers of insulator, double layer. Usually solar cable, if you cut it, you can see the double layer. Usually. If the normal DC cable tu, battery cable for example, only like this lah I think. Okay. So this the insulator lah. You try to cut the DC cable, any DC cable, because there's copper here. So this is the copper. If we use copper, so the copper is inside there, and outside of that is the insulator, and that's why we cut it, and we easily can see the copper just like that. But for the solar cable, usually they have the double layer of the insulator lah. That's why for the purpose of the UV, UV resistant, highest temperature, and the flame retardant. Okay, so 2.5 meter square can goes up to 24 amps. Okay, that one for 2.5. If 4.0, like I told you, if the for the modules with the watt of 100 watt and above, usually they equipped with the equipped with the 4 millimeter square, all in one. I mean, they give you the set package, maybe 0.7 meters only, or 4.0 millimeter square. It can goes up until 32. Sebenarnya, even the solar farm also can support. That's why we don't have to add another budget for the thicker cable. If we use Huawei, we can use 4.0 just like that, because we use only single or double string only. One module less than 10 amps, so 20 amps maximum. So which no problem with the 4.0 punya cable. There will be no problem. No need to change to the thicker one. We can just use as it is at the back of the solar module. Just connect it in series. Okay. How to calculate that one? Okay. We referring to the IC STC string. For example, our module is 7 amps, so this is the 14 amps. So 14 amp I minimum string tu is 40 amps, so we need to find the cable that can support minimum 40 amps, which is I think here you can use Titanex 17, Titanex 11 for example, but the best one you can use Redox lah. The highest better lah. At least we can check. We can check. If the value is higher than our calculation, so we cannot use the thicker cable lah. I mean the thinner cable lah. You need to use the thicker cable one. Just the cross section. I mean we need to check it. Okay. Usually, like I told you, if the single string or double string, no problem for the 4.0 millimeter square cable. And because here is 34, and 34 means no 45. So sorry. If 4.0 can goes up to 45, which is recent solar modules, solar farm, they're connected only one series to the one channel of the inverter, which is still in the range. No problem. Okay. Ada soalan tak? Aku macam cakap seorang. Hafiza Ali. Hafiza Ali. Can you understand? Faham tak? Faham ke tak? Faham? Boleh? Okay. Syahira Fazil. Syahira Fazil. Faham ke? Senyap aja Syahira ni. Syahira ada ke? Tak ada? Syuhada Maisara. Siapa jawab tu? Siapa jawab tu? Okey. Alright. Boleh Seorang lagi tanya. ID. Boleh faham ID? Boleh Bismillah Okay. Right. So now next, so kalau faham, we are proceeding to the next part, which is the cable size. Now we are going to the cable size, how to calculate the cable, how to select the cable. Okay. Same. I'm referring directly with the book published by the SEDA for the GCPV course. It is clearly written here. So riwayat saya sahih lah. Okay, sahih. Okay. Saya tarik betul-betul daripada buku yang GCPV course tu. Okay. So when designing system, the string current is known once the module selected, while the DC main current is known once the size of the array is specified. Okay. What must be determined is the minimum cable size required. Minimum cable size required to meet the required voltage drop. Okay, to meet the minimum voltage drop. Let's say maximum voltage drop allowable, like I told you, is 3%, for example. So the cable must must fulfill this requirement. Okay, how to calculate that is very super simple equation here. You can see the minimum scale size are calculated as blah 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 blah. Very simple equation, but need slightly deep understanding. Okay, there's different. Okay, I'll explain. Okay, first we are explaining the parameter here. So ADC cable is the cross section area of this cable, which is the cable size. So this is the cable size. We call that as the cable size, right? Then we have 2 multiply with LDC cable. What is the LDC cable? Is the length of the DC cable. Okay, it's the length of DC cable. Okay, why they have two? Okay, later I will explain. Let me introduce also the character. The character. What's the IDC? IDC is the DC current. Okay, DC current. If in the question is written maximum DC current, blah blah blah, so you just put that value. If doesn't say anything, then maybe it get confused whether you want to use IC or IMP. Okay, both can be used, but the preferable is the IMP one lah. If for the case of IDC. Okay, tak apa, tengok dulu. Okay, and then we have the rho here. What is the rho? The sensitivity of wire for the case of copper, because we are using copper and aluminium. Say 1/56. I think this is value of 0.017857. If I'm not mistaken, if we divide 1 with the 56, you can get this value 0.017857. Okay. Next character is the loss. What is the loss? Maximum voltage drop in conductor. Okay, this value is the voltage drop given in the question, or if it's not given, the maximum allowable, which is the 3%. Which means the loss value is exactly the percent of the voltage drop. If 3%, then 0.03. If 1%, then the value is 0.01. Okay? It's not like the before. F berapa dia tu? Benda tah? PV inverter ke apa? Sebelum ni. Yang kita tolak 1 minus voltage drop. Kan? Then you get 0.97. This is the derating factor. So that's why 1 minus 3%. But for this case only, loss, you're going to take the value of the voltage drop exactly just like that. If 1%, then 0.01. If 3%, then 0.03. Like that. Okay? Then we have the VMP string. Okay, what is the VMP string? You know already. Okay, is the VMP STC multiply with the N module in the string. N string lah. For example, if one string we have 5 modules. One string we have 5 modules. And each module, for example, 20 volts. Okay, each module 20 volt. I mean the VMP STC for each module 20 volt. Means that VMP string is the 20 volts multiplied with 5, which is 100 volt is the VMP string. Remember, VMP string, not the VMP, the single VMP STC. Okay, so this is the character for this equation. All the characters are defined as the equation. Okay, I go back to this part. Okay, please focus. This is very critical. Okay, critical. Okay. The length of the cable. Why it is multiplied with 2? It is because if the length of the cable plus and minus are in the same length, 2 multiplied with the DC length. Saya repeat. Contoh. So this is the PV array and this is the inverter. Okay, inverter. This distance, this length is the LDC cable. Okay, 2 multiply, the meaning of the 2 is because we have two cables. Like highway lah, highway. Okay, one is the black and one is the red and one is the black, ataupun one is the positive cable, another one is negative cable, because we have two cables in the same in the same distance. They have two cables there. That's why 2 multiplied with LDC cable. LDC cable is the distance between the PV array to the inverter. Okay, that's why 2 multiplied with LDC cable. That is the meaning. Okay, why this important? Why this is important? Because the question can be twisted with the different wordings. For example, there's one condition. Okay, one question for the one about the length of the cable. Okay, they play with the tricks. Okay, the distance between the PV array and inverter is 10 meters. So distance between PV array and 10 meters is PV array and inverter is 10 meters, means that finally that you are going to use the 2 multiply with 10. In other words, total cable is 20 meters. Total cable use for this system is 20 meters, not only 10 meters. Because we have cable, positive cable and negative cable. That's why 2 multiplied with 10, then the total cable use is 20 meters. Okay. That type of question, when they say the distance between the PV array and the inverter is 10 meters, means you need to use 2 multiply with 10. So this is the first case. What is the second case? The second case, the total cable use in this system is 30 meters, for example. Total cable use in this system is 30 meters. Means that the budget that we have for the system is only 30 meters. So we have only one cable lah with the 30 meters. What is the length, how much is the length of the positive or negative is not given. It's not stated. So at that time, 30 meters are going to replace this two item. Boleh ke? Not 2 multiply with 10. Okay? Not 2 multiply with 30. But only 30. Only 30. Only. Without 2. 30 meters. Boleh faham tak? Azik. Boleh dapat tak maksud dia apa? Total cable length tu maksudnya dia akan replace the value 2 multiply with LDC cable ni. Kalau dia sebut total cable route use in the system. Maksudnya kalau awak buat 2 darab 30, 2 multiply with 30 is wrong. Okay, wrong. It's only 30. Boleh OWI. Boleh OWI. Boleh Ya. Yeah. Tak perlu bagi 2. Tapi tak perlu darab 2. Tak perlu darab 2 dan tak perlu bagi 2 pun. Boleh ke? Yep. Okay, I give you the third case. Dia ada third case lagi. Okay. This is the second case. It means clearly stated the total cable route used for the system is 30 meters. Means tak ada 2 darab. No 2 multiply. No. Only 30. Okay. There will be the third case. The third case very straightforward. Positive cable 10 meters. Negative cable 15 meters. Okay. For this case, we are going to write like 10 plus 15, which is total 25. But the clue here, 10 plus 15 will replace this 2 multiply with LDC cable. Boleh? Boleh tak? 10 plus 15. Okay, maybe you ask, why the cable length is different, positive and negative? We are connecting in same. It's actually logic, because when we do the installation, definitely there will situation where the either cable positive or negative are longer than the others. That's logic. When you do the cabling kan, kalau you potong cable pun, buat installation pun, you sambung connecting cable also, it will not same length kan, because of the route. Maybe there's some obstacle on the plus side, that's why both cable length are not the same. That's logic. Okay, that's logic. Not only 10 meters plus 10 meters, if the same, okay lah, but it's very logic and possible when the cable positive is different to cable negative. Okay, but this one will replace 10 plus 15 will replace 2 multiplied with LDC cable. Boleh? Dekat sini, because it is given clearly, positive cable how much, negative cable how much. That's why kita just add up 10 plus 15. For the first case, they just give you the distance between the PV array and inverter is 10 meters. They don't say the cable is slightly longer or not. They just say the distance between these two area, these two equipment is 10 meters. So means that 2 multiplied with 10 meters automatically. Okay. We assume that the same, the plus and the negative cable are the same, in the same length. That's why we 2 multiplied with 10 only. Okay. Second cases, ni quite tricky. Total cable route. Total. The wording is total cable route for the system. Very general value. So you don't have to think to divide or multiply. You just use exactly the 30 meters as it is. So means that kat sini 30 meter multiply with IDC directly. Okay. Boleh Oi? Boleh dapat? Ganesh? Ganesh? Okay, understood? Boleh? Okay, boleh lah tu Mak Kelvin? Okay, understood? Irfan? Muhammad Irfan? Boleh Okay, bismillah. Okay, let's proceed. Okay, let's proceed. Sikit lagi. Okay, sikit lagi we are going to finish the chapter Grid Connected. Next Wednesday, we are going to the standalone so I want to finish it. Okay. I think less than 30 minutes good. Okay. Alright. This one is for the cable size. What is next? Kita ada example yang insyaAllah it will help you to super understand it. Okay. A PV string comprises of 7 modules. Okay. A PV string comprises of 7 modules. So means that we have a single string with the 7 modules connected in series. Okay. This is not D, this is the module. Okay, this is the module. Just assume this module lah. Don't question too much Okay, where each module produce 5.35A, I believe this is the IMP, and 19.7 volt, this is also VMP, maybe, of current and voltage respectively. Since the distance between this PV string and the combiner box is 10 meters, so the distance between here and the inverter, this is inverter, 10 meters long. Okay, 10 meters long. What is the suitable size of cable to be used for the system? So assume resistivity of copper wire and voltage drop are 0.017857 is equal to 1 over 56, and 2.5% is the loss. I told you, loss 2.5%. Okay, what is the equation? The solution is to use this equation. Okay, So in this case, what should we put here? Yang ni we know lah. Yang ni 5.35. This is 0.017857. And this is a 0.025. 0.025. And a VMP string is equal to what? Kira jap. VMP string. Fatin Adawiyah. Berapa VMP string? Sekejap. Siti Noraini. Berapa? VMP string. VMP string. Betul lah. Berapa tu? Uish, apa ya? Kau pakai sempowa ke apa? Pakai sempowa. Kau je buat. Ya. Betul 137.9. Betul ke Ashraf? Ashraf Aziz. Thank you ni Fatin. Betul Betul lah tu Okay. Okay, what about dia ni? To multiply with IDC cable, what should we write here? Syahmi Hafiz. Syahmi. Ya pula Syahmi ni. Tak ada. Ridwan Arif. Tak ada juga. Naufal. Tengah kira. Punya lama tengah kira. Nak tulis apa tu? Sekarang kira tu kira lah. Kita nak tulis apa tu? Kita nak darab apa tu? Kita nak kena buat apa? Tu soalan saya. Kita ganti value apa? Kita ganti value apa? Apa benda? ADC cable tu. Masanya 2 darab 10. Macam tu? Macam tu ke? Ya, ulang balik Nafal. Saya tanya Nafal dulu. Kau nak 2 darab 10 ke? Kau nak 10 saja ke macam mana? Cepat. 10 kali? Keliru dah ni. Rasanya 10 je. Maksudnya apa 10? Maksudnya tak ada 2 lah. 2 tak ada. Okey, 2 ada. So 2 darab 10 lah maksudnya. Betul lah tu. Kena confident lah. Ragu lah dia. Kita ganti dengan 10 je lah. Betul lah tu. Tapi 2 ni masih ada lah. Okay, 2 ni masih ada. Sebab apa tau? Distance between this PV string and the combiner box. Tak apalah, ni sebut combiner box. Inverter sama lah. Tak salah. Maksudnya distance dari situ kepada combiner box tu adalah 10 meters. Okay, adalah 10 meters. So, maksudnya ada 2 kabel lah kat tengah-tengah ni. Plus dan minus. That's why kita kekalkan 2. So 2 multiplied with 10, multiply 5.35, then you get 0.01. Ni tak kira pun tadi. Fatin kira kan ni kan. Then dapatlah 0.5542 mm square. Dapat tak? Roger Gun. Roger, did you get this value? Okay. This is the cable size that we calculate. So means that this system needs the cable size with the size of 0.5542 meters square. However, we don't have this type of cable kan. We don't have the 0.55. Who are going to do for you kan? That's why we need to choose the available cable size in the markets. Okay? Maksudnya kita pakailah kabel. So kalau daripada sini kita ada 1.5, 2.5, 4, 6, 10 and so on. So which one is the most suitable size cable to be used? Itu adalah soalan dia lah. What is the suitable size of cable to be used for the system? Saya nak tanya Faizuddin. 1.5. 1.5 Okay, tak apa. Thank you. Kita tanya orang lain juga. Hasif Azman. Kabel apa yang sesuai guna ni? 1.5. Okay. Tanya Azuddin. Izzuddin, cuba Izzuddin. Berapa? 1.5. 1.5 Okey, Amirul. Wah, ni makin lama makin naik ke atas ni. 1.5. Okey, berapa orang? 6 orang. Radhi. Hello. Kabel 1.5. Okey, 7 orang. Zulfikar. What is the size, the cable size for this question? We calculate 0.5542. Apa? Nanti. Uish, kau ni siapa ni? Nafal ke? Kau ni tuan main rodok je. Aku tak tanya kau. Jangan jawab. Nanti. Tak tanya tadi. Jangan Zulfikar. 1.5 Okay. Last. Alia Ashifah. Berapa? Kabel. 1.5. Okay. Berapa tadi? 8 orang. 9 orang 99 1 minit. 99 1 minit. Okay. Macam ni. Among these sizes, the closest one that is compatible with 0.5542 meter square is 1.5 millimeter square based on this calculation lah. Betul tak? Semua pun setuju dengan 1.5 kan? Akan tetapi kan, aku tetap terminate korang. Sebabnya, kita tertakluk kepada satu kitab. So, based on the Malaysian standard with the code of 1837-2018. Ini sama sekali, standard yang sama untuk 3% allowable voltage drop. Okay. The minimum cable size that can be used is 2.5. So, what you did, you calculate to based on the calculation is correct. Of course, it's correct. But because we are limited, we are bound with the Malaysian standard, which is 2.5 is the minimum cable size to be used for the case of DC system ni. Okay. Yang ni, don't get confused with the cable wiring AC biasa kat rumah installation. That one is different. That one will be depends on the load kan. Kalau you use air conditioner, water heater 4.0, air conditioner 4.0 for example, and then plug 2 points maybe enough for 20 amps and for example like that. No, that's different. That's the low voltage electrical installation. That is for the AC installation. But for the case of DC cable, because we are grounded by this standard, so there's 2 items here. One is the 3% of voltage drop, allowable voltage drop, and another one is the minimum cable size to be used is 2.5 millimeter square, not the 1.5 millimeter square. Boleh? Okay. Walaupun saya dah terminate, boleh minta kerja hantar resume balik lah. Macam tu. Boleh? Boleh minta kerja balik. Gitu. So Nafal tadi kan, apa darat dengan 7 Nafal? Mana Nafal tadi? Kau punya teka kau bahaya betul lah. Ini boleh terminate awal-awal ni, suka main teka ni. Kena ikut kitab lah, kena ikut kitab. Standard. Macam tu lah. Tak. Maksudnya macam tu lah. Maksudnya kita we are limited with this standard lah. So minimum, remember, even though you calculate, you get 0.1103 millimeter square, still 2.5 meter square based on this standard. In your answer, please stated this. MS1837 2018. Okay. 2.5 meter square is the minimum cable size that can be used. Boleh? Ramai dah kena pecat Okay. Termenung semua. Macam tu lah. Okay. Boleh Siapa yang tadi dah kena terminate tadi tu? Radi dah kena terminate. Amai yang kena terminate Asif, Esudin, semua kena terminate. Amirul, semua kena terminate Gurau. Okay. So ingat benda tu. Alamak. Ada yang bagi ni ke? Kalau ada bagi apa-apa saya tak nampak nak baca lah. Saya tak bawa skrin satu lagi. Okay. Alright. Okay. Boleh settle itu. That is the story of the cable size. Now we are going to the voltage drop. Okay. So we are going to calculate the exact estimation, approximation of the voltage drop after we choose the cable or after the cable is chosen for us. Remember, the voltage drop is calculated not based on the value here. Not value here, but the cable that we choose. We must refer on the standard size cable. Means that if teruskan. Oh, ini memang Malaysia standard punya. So kita kitab Malaysia je lah. Malaysia standard. Ni memang ada buku Malaysia standard. Yang tu download tu macam tak boleh download sembarangan tu. Dia macam kena pakai kona-kona sikit lah. Macam tak boleh download sembarangan tu. Saya cuba download juga. Tapi saya dapat lah. Ada lah standard tu rasanya. Pernah nampak lah. Ini Malaysia case lah. Sebut lagi Malaysia standard kan. Tapi maybe they adapt from the international lah. Overseas lah. Saya rasa dia benchmark macam tu juga kot. Tapi for case macam tu lah. Boleh? Okay. So, after we choose the cross-sectional area, I mean the cable size, the what we call it, commercial standard cable size tu. So, adalah kan cross-sectional area tu lah yang 2.5, 4.0 tu kan. So, voltage drop in the wire are a function of 3 parameters. Remember, the thicker, I mean the thicker the cable is, I mean the higher the cross-sectional area, so the voltage will be reduced lah. If you're using the bigger cable of the apa panggil tu, cable besar. Okay, the bigger cable bigger size of the cable, so it will totally reduce more voltage drop lah. But the trade-off is about the cost. Okay, when you use the thicker cable, so the costs are more lah. That's logic lah. And then what is the cross-sectional area? Yeah, people are trying to suppressing to the lowest cost kan. Contoh, saya bagi contoh. Maybe standard practice, but I think is actually against the standard guideline from the Suruhanjaya Tenaga, for example. Okay. But this one example for the AC installation. For example, aircon, air conditioner. Maybe some of you went to internship or some from diploma, and then you get used with the voltage, I mean the electrical wiring. Okay. Based on the standard, I mean the Suruhanjaya Tenaga guidelines, for the air conditioner, the cable size to be used is 4.00 millimeter square. Okay, it's 4.0. Okay, but I believe lots of installator panggil apa panggil? Installator pula. Lots of installers are using 2.5 millimeter square of cable for the air conditioner. Okay? But if we refer to the standard guideline, ST guidelines is actually 4.0. Boleh check guideline tu. Yang wiring punya kabel tu. Semua is all written in the guideline. Tapi itulah, saya tanya pun that person also say the same thing, 2.5 is enough kan. But I think maybe I'm wrong. I recheck again, still 4.00 millimeter square for the air conditioner cable installation. Contoh, that's different. So that one is the based on the standard Suruhanjaya Tenaga lah. Okay. Okay, it's just example situation. Okay, length of wire, the longer the cable is, of course, the more voltage drop can occur. Okay, can occur. And then current flow in the wire also will CCC tadi lah. Okay, CCC tadi. When we use 2.5, maybe can go until 24 amps maximum. But if we use 4.0, it can go until 36 or 32. I forgot. Okay, that's the point. Okay, voltage drop in the cable due to resistance is the result of power losses in the cable. Excessively long cable. Okay, excessively long cable can result in loss of power to the inverter. I think you know already. You learned already in the EPS. Okay, already learned in electrical power system. And maybe for those who have been in the internship also, who are doing the installation, so to get used with that. Okay. This is not wrong. I mean, this is not the typo, but I purposely, what we call the cross it. Okay. On MS 1837 2010, the voltage drop is less than 5%. This is the old Malaysian standard. 2018, they have revised and they have increased. No, they have reduced. The maximum allowable voltage drop is 3% only. So we are following the latest one, which is the 3% only. The allowable voltage drop for the DC solar system. Okay, DC side. Boleh? 3%. 3%. If you answer 5% in a question, for example, maybe depends on my mood, maybe I can give correct answer. If at that time I'm bad mood, so I just follow the standard lah, which is 3%. Okay. What is the difference between the equation with the previous cable size? Only this part. And extremely easy. It's the same thing, it's the same cases like before. Like I told you, if the total cable route given blah blah blah, so just put only one value, 30 meters only. It's the same cases with the cable size. But the difference only at the down part, which is the, here comes the size of the cable. This size of the cable that you choose just now. For example, 2.5. For this is the 2.5. Not the 0.5542 meter square. This is wrong. Totally wrong. Cable is the size of the cable. Okay. Whether 2.5, 4.0, 6, 10, 16, 25, and so on. So that is the size. Okay. Then you calculate as usual. Yeah, you're going to get the V drop. Okay. The voltage drop. Okay. 3.5 dah. Alright. Learning without practice is just the people without head. Macam tu kan? Bukan. Tak ada guna-guna. Okay, sorry. So maksudnya, we need to do the exercise to better understanding lah. Again, almost the same example. A PV string. Okay, means that we have the one string and comprises of 7 modules, where each module produce 5.5, 90.7. Again, is the series of the modules, which is we are going to have the PMP string, which is 19.7 multiplied by 7. So that is the value for the PMP string. Okay. The distance between the PV string and combiner board is 25 meter. Oh, sudah panjang lah. Sudah bertambah 25. So 25. Distance between PV string and combiner box tanpa ragu-ragu, it will remain 2 multiplied with 25 lah. Which means that this just put the 25 here. So it remains 2 multiplied with 25 because the distance between the PV string and the combiner box is 25 meters. Okay. And then if 2.5 millimeter square of cable set is selected, estimate the possible voltage drop percent. Assume resistivity is same value. Then we just key in the value as simple as A, B, C. Okay, 2.5, and this is 5.35, and this is the row. Row is 0.017857. Okay, without thinking too much, just calculate it. Then you are going to get the value of 1.9107 volts. This is the voltage drop. Okay, but the question asking you possible voltage drop and is written in percentage. So we need to take out the percentage value. This is not the percentage. Apparently, this is not a percentage. So in order to produce the value of percentage, what should we do? Okay, what should we do? Jamadil Akbar. Jamadil. Tak ada. Wani. Nur Wani. Tak ada. Apa ni? Mirul. Amirul. Muhammad Amirul. Ha. Ulang balik sekali lagi. Sekali lagi. 19.7. Ha? Okey. Oh, salah lah. Salah. Salah. Okey. Macam mana? Ambil PMP. Cuba sebut. Macam mana kena ambil itu. Okey, lepas tu? Nak buat apa dengan tu? Tolak dengan voltage drop. Salah, tapi cara ambil tu macam dah betul dah. Parameter yang kau ambil tu betul, cuma cara pengiraan tu salah lah. Ya. Yeah. Okay. Ulang balik. 1.9101. 1 point je Okay. Okay. Hampir saja. Tak betul lagi tapi dah hampir betul. Dah hampir betul. Ya, orang lain. Farhana. Macam mana tu? Tadi Gini cakap yang ni dah hampir betul tapi masih salah, tapi dah hampir betul. Betul. PMP string. Okay. Ini betul. So, okay, thank you Fana. Apa nama? Jawapan dia adalah V drop DC ni bahagi dengan VMP string. Okay, string. So, ini dapat daripada sini. So, ini adalah 19.7 darab 7. Then, dapat macam ni. Then, dapatlah 1.3856%. Ini still less than 3%. So, maksudnya, okey lah. Kabel ni okey, suitable. Boleh? Yang lain? Siapa akan panggil? Boleh. Fadilah. Siti Fadilah. Boleh ke Siti Fadilah? Okey. Uh, Muhammad Haziq. Boleh ke? Muhammad Haziq. Boleh. Alhamdulillah. Okey. Last. Oh, ada lagi. Bukan last lagi. Ada lagi. Alamak. Alamak. Apa dah? Okey. 337. Alright. Next is the power loss. However, the equation is not that difficult. The difference only very slight to the voltage drop. Okay, it's the same thing. Just we want to calculate the power loss. Okay, ni kira sama je. Okay, what is the difference between that? Is only here. Okay, ada kuasa 2. Just now we don't have any kuasa 2 here, but now we have the kuasa 2. Okay, then we can get the power loss. Remember, we focus only DC. Okay, DC side only. I'm following the book published by the SEDA for the GCPV course. So, sahih. Sahih. Okay. Alright. So, the same example I use, the different only this value. Okay. Then we get 10.222 watts. So, 10.2222 watts. So this is the power loss obtained from this configuration or arrangement. Okay. Beza dia ni je. Beza dia dengan voltage drop tu ni je. Voltage drop tak ada ni. Voltage drop tak ada. Tak ada. Kuasa 2. Tak ada kuasa 2. Okay. Alright. Last part. Okay. So PV system. Oh, ya. Yeah. Siapa tu? Again. Oh, you mean the power loss is from the mismatch? Like that? We just consider from the not mismatch, just we calculate directly from the loss, from the voltage drop that we calculate. From there, we calculate the power loss. I mean, once we choose the cable, we can calculate already the power loss based on the length, based on the current flow in there. Very straightforward. Okay. Yeah. Yes. Okay. Yang ni, lupa nak mention banyak kali. Yang ni, kita ambil IMP. Boleh? Sekejap. Aku tunjuk yang, sekejap. Kenapa ambil IMP tu? Sebab dia tulis IDC je. No. Tahu nak kata balik. Because here is VMP string, so here we take the IMP. Don't take the ISC lah. If you take ISC, then the pair is VOC. Take ISC, the pair is VOC. So because we take VMP string, so the pair is IMP lah. IMP from datasheet module. Okay? Or it is declared in the question like this lah. Macam ni. Boleh tahu kan? Current, apa-apa current lah. Tak kisah. Sebab tu tulis IDC tu, dia mungkin bukan IMP-SCC pun. Maybe ada current yang dia letak. So, kita tengok soalan lah. Kalau soalan tak bagi apa-apa, memang kita refer modules tu punya IMP. Macam? Baik. Okay. If it's the performance, it is the system designer job to provide an estimate of the energy yield. Energy yield ni samalah energy system. Kita dah belajar sebenarnya energy requirement tu. Okay. This information may be provided as annual yield, or since the available solar radiation does vary throughout the year, it can be provided as the monthly yield. Okay. PV energy yield can be calculated as this value. Okay, maybe we calculate before, but at that time, there's some value that, for example, the inverter is not decided yet. if you still remember, when we try to choose, okay, we design criteria based on the energy requirement. At that point, the inverter efficiency is not given because we need to assume. At the time, we assume 0.95, right? But at this moment, after we calculate all the cable size, then we are going to get, we choose already the we choose already the solar module, we choose already the inverter. So this one, you need to replace with the exact value of the inverter efficiency. For example, 0.987. So this is the value of inverter. Then another one is coming from the voltage drop. So this is coming from voltage drop. This is what we call, we calculate just now. And for example, that one we get apa 1.8%. So that one means that 1 minus 1.8%, maybe we get 0.998 2. 0.982. Before this, maybe we consider 3% kan. After we calculate the cable size, then we get the voltage drop exactly percentage. Then when asked for the energy yield, so we are going to put the real value of this. Then we get the correct. The energy yield. Okay, energy yield. And before that, we design based on the energy requirement kan. But this time we are going to calculate the exact value of the energy yield after we calculate voltage drop, after we chosen the correct efficiency of the inverter. Okay, right. That's one. And this is the energy yield. Next, specific yield. Uh, Specific yield, even you ask me what is the real meaning of specific yield, to be honest, I don't know. I just follow the book from this Seda kan. They just write there for the performance, they using the specific yield, and then they have the performance ratio. Okay, the third one is the performance ratio. Okay, specific yield, okay, is the E system. Just now we calculate N. So this is the kilowatt hour, right? The unit is kilowatt hour. So this is the E system, energy yield. Another one is P array STC. Okay, P array STC is the system is coming from the our PMP STC multiply with N module, right? N module, okay? So yeah, okay. So this value is going to be kilowatt peak. Okay. But the one thing that you need to be very careful, the specific yield, but actually it's not that cost. It's not cost. It doesn't cost much in the marks, but it's okay lah. The unit is kilowatt hour, kilowatt peak minus one, minus one. Okay. This is the unit of the specific yield. Though we can cancel actually the kilowatt, but that is not the case. For the case specifically for this item of the specific yield, the unit used here is kilowatt hour over kilowatt peak. Okay. Okay, we're not cancelling the kilowatt. We just remain it as like that, as it is. Okay. So kilowatt hour, kilowatt peak. So this is the value for the specific yields. And this one is not cost much in the marks. I think maximum 2 marks. Okay. But still, this is the how we uh, evaluate the system performance. Okay, and the one is the performance ratio. So performance ratio is the E system still the same. Okay, is the kilowatt hour, and the E ideal. So E ideal, ideal energy output from the PV array at STC. PV array at STC. So the Y ideal. Okay, the Y ideal is equal to the P array STC multiplied with P array STC multiplied with PSHPA. This one also in kilowatt hour. So cancel. Then it will remains as the value of percent. Percent, for example, 0.7 or 70%, like that. Okay. There's no unit specific, only percentage. Okay. So PS60 multiplied by PSHPA, that is the E ideal. Ideal energy output from PV array at STC. So this is the space. So mean for the system performance, we have the energy yield, we have the specific yield, and we have the performance ratio. So maybe that one, I think the minimum for these three is no, minimum for the specific yield 2 marks. Minimum 1 mark, maximum 2 marks. Same with the performance ratio. It's not cost much. I mean the marks. Okay, it's not that much. I think. Last. Okay, last. Ada lagi last example. 47. Okay, 47. Mormon. Okay, Mormon promises his client that if his design proposal of a 7 kilowatt peak system is receiving enough annual irradiation of 1526. So clearly this is the annual irradiation, which is the PHPA. Okay, PHPA. This system is expected to yield at least 8.6 8,600 kilowatt hour. So this is what? Energy yield. This is the E system. Okay. What is this? This is the P array STC. Okay. Based on this claim, estimate the specific yield and performance ratio for this system. Kita tahu specific yield sama dengan equation ada tak sini? Kita lihat. Oops, sorry, ternampak. Is E system over P array STC. So this is the specific yield. So A system is the 8,600 kilowatt hour over 7 kilowatt peak. Then you got 1,228.5714 kilowatt hour per kilowatt peak. So this is the unit lah. Okay, this is the unit. Please remain as it is. Don't leave at the hour. It's wrong. Okay, just leave it kilowatt hour over kilowatt peak. And then performance ratio, PR, not performance resident, is performance ratio. E system over P array STC multiplied with PSHPA, which means that P array STC PSHPA, then we get 1526 is here. And then this is 7K, and this is the 8,600 kilowatt hour, which is here. And finally, we get 0.8051 or 80.51%. Okay, so this example of the calculation for the specific yield and also performance ratio. At this point, we have finished covered the whole grid connected PV system punya chapter. Okay, punya chapter. So the assignment will be released within this week, but the submission okay lah. Study week, something like that. Okay. Maybe after study week lah, study week for 4 weeks. Any question? Tak ada soalan? Tak ada soalan ke? Yeah. Yeah. Means that if you calculate exactly 2.5 or what? 2.49 or what? Again, 2.49, 2.5 something. Okay. 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 If 2.5 exactly as the calculation, we choose 2.5. If exactly 2.5 without pointer at the back with decimals. If 2.6, then 4.0. Okay. Any other question? Hmm. Hmm. Okay. By default tu memang kita ambil 0.017857 kalau guna copper lah. Kalau yang biasa punya solar cable tu dia guna copper. Saya tak jumpa lagi aluminium. Pakai aluminium. By default tu lah value dia. Okay. Soalan last question. Hafizah Ali ada question. Syahira ada question. Ada Uh, okay. Last. Mardiah ada soalan? Tak ada. Okay. If no question, so we finish here. Then we are going to go to the next chapter of standalone. Chapter 4, we return back. Chapter 4, standalone. So standalone on Wednesday lah. Okay. So thank you and masih selamat hari raya. Okay. Terima kasih.